My name is Kenneth Chang, and I will be presenting Lab 2 Charge Tapes Revisited for Physics 2212. So this is just a recap of Lab 1 since we used the same experiment for Lab 2. So the purpose of this lab was to create temporary charges on clear tape, observe how they interact with each other and other objects to determine the charges, and create a computational model of line charges. So the main result that we observed from this lab was that the electric charge of the tape was 2.107 e to the negative 8 coulombs, and that line charges are more realistic in modeling this lab than point charges. So the fundamental physics principles used in this lab are Coulomb's law to calculate the electric force and the electric field of the charge tapes. And we also use Newton's second law, in which we use to calculate the electric charge of the tapes by setting it equal to the force of gravity. So some assumptions that we made in this lab were that we neglected air resistance, the pieces of tapes were equal in charge, and the charges are evenly distributed along the tape, and that the tape charges are positively charged. So moving on to the experiment, the system is tape B, the tape on top, and the surroundings is tape A, the bottom tape. And some initial conditions are that we have two neutral pieces of tapes. The masses of the tapes were 2 times 10 to negative 4 kilograms, assuming that they are exactly 8 inches in length. And the length is zero point 0.2 meters or 8 inches. So the procedure was that we stick a neutral tape onto the table completely flat, making it the base tape. Then we stick the U-tapes onto the base tape, and which we rapidly remove the U-tapes, and this creates a positive charge. We then hang the U-tape off the table and bring neutral objects in proximity to it. So part B, we prop tape B on an elevated surface while making it too taut, and then we place tape A underneath tape B to see if they repel and measure the distance. So in our calculations, instead of using the formula for the electric field of a point charge, we use the formula for the electric field of a rod, or because the tape is a thin rod, very thin rod. So we use this equation, and then we set the magnitude of electric force equal to the magnitude of the gravitational force. And in our calculations, we found that the charge of the tape was 2.107 e to negative 8 coulombs. So moving on to the computational model, we first defined our variables, which the mass of the tape was 2 e to negative 4, and our charge, which we calculated, was 2.107 e to negative 8 coulombs. And we created a function where we calculate the electric field using the observation location in the charge particle that we later call later in the code. And then this function was given to us, but it creates a line of n uniform point charges with a given total charge. And we then call this line charge function to create the top tape and the bottom tape, which is just a bunch of point charges put together. And our number of point charges put together is 20 for each line of tape. So the computational model, uh, moving on more towards the code, we calculate the electric force and the electric field of the top tape due to the bottom tape. So we do this by iterating through each piece of charge in the bottom tape, and summing up those forces and fields. Um, we then we then create a arrow to represent the electric force and an arrow to represent the electric field. And then when we run the code, these are our results. So the green arrows represent the electric field due to the bottom tape on the top tape. The white arrow represents the magnitude of these green arrows, and the yellow arrow represents the force of gravity on the top tape. So, what if you had modeled each of your tapes as a single point charge, like in the previous lab? So in lab 1, where the tapes are modeled as point charges, the estimated charge of the tape was 9.33 e to negative 9 coulombs. In lab 2, where they are now modeled as line charges, the estimated charge of the tape was 2.107 e to negative 8 coulombs. This is a 55.7% decrease. So why do these estimates differ? They differ because the point charge model simplifies the tape by treating all its charge as concentrated as a single point, which leads to a lower charge estimate. In contrast, the line charge model distributes the charge along the tape's length, making it more physically accurate and resulting in a higher estimate.